All right, good morning. My name is Conan Morgan. I'm here to help tell you how to assemble and put together the actual Detector Building event for the 2020 Science Olympiad. So I'm super excited for you to be here. I want to go over a couple of details, try to take out some myths of how this thing is supposed to be working and have a setup, and help you really plan on how to actually run the device as well as the actual competition. So this is the building portion of it. This is the part that has to be pre-built before you get to the actual competition. There's a test taking and a measuring section of this particular event. The test taking one is literally like every other event in the Olympiad. You've got some multiple choice, some free response, some fill in the blanks, and some calculations you're supposed to do all around thermodynamics and different things that are specific to temperature gauging portions. Detector building is literally trying to detect something that actually be a standardized measurement. This year's standardized measurement happens to be temperature. In years coming, it could be air pressure or any other thing that you think we actually have that can be measured at a normal standpoint. A couple things that you're going to have. I know the rules speak directly to a TI-84 calculator. This is one of those here. It has an actual USB connection here at the top. This is standard for most folks who are actually in class in high school. You could be able to grab one of these and be able to use it. You need to know some of the programming, so I advise you to go to the national website, download the actual programming information for that, and learn how to use it when it's connected to an Arduino. If you don't have a TI-84, if you want to be fancy and actually have a laptop, you can use a laptop. I brought mine here. Standard Mac is fine. You can use it however you want to. Just something that has a USB connection, because you need to actually have an Arduino breadboard connecting to that, to the actual USB device. You can't do simply on an actual Arduino by itself. You either need an actual calculator or a computer, because you've got to modify the code and the programming to be able to calibrate to your temperature. So that's the first thing that is required for what you need for today. A couple things. You will need a breadboard and Arduino. That is standard breadboard. Could be as simple as this. It doesn't have to be anything overly large. Some type of electronic mechanism. I have an extra piece here that has a USB connector from this Arduino kit. I bought this Arduino kit on Amazon for about $20. So it's very easy to assemble and be able to put things together. It comes with a how-to, and it also allows you to be able to go online and look at YouTube videos on how to put it together. LED sensors, red, green, and blue. It could be anything like this. These particular bulbs are already pre-colored, as you can see. So nothing fancy here. We do have some students that want to kind of get some bonuses, so you may see a clear one versus something that is actually going to be a color. This is blue, okay? It doesn't matter if it's clear at the beginning or if it has a blue bulb. If it is clear, you need to be able to tell us what color it's going to turn. We do have some students that have been very fancy about having it so that it's a multicolored LED. That is completely fine, but when you actually have the color display light up, we need to know exactly what color we can expect. And it does have to be 3 bulbs, not just one. Then, probably the most important thing, this is a thermistor. These thermistors here, you can buy a pack of these on Amazon for $12. There are 10 of them that come in a box. Let me grab my box over here. So this is an example. Be able to look this up and see that these are thermistors. If I was to open them up and actually open the box, you've got multiple in here. This is literally what's going to be your temperature gauge for it. Now, with that said, we've got a situation by which we need to actually put this thermistor in an actual device, likely a straw, and stick it into an actual cup that has some type of solution in it. Water is what we're going to use, okay? So the first thing that comes to mind is, oh, I'll take something like a coffee straw, and I can stick my thermistor in the coffee straw like this, right? It seems like it's almost a perfect fit. Now the problem here is, this thermistor, if I stick it directly in the water right now, it's going to short out immediately because we did nothing for adhesive to keep it in. The first thing this actually is going to fall out. The second part of it is, you need to be able to tape it and make this waterproof, like it's an actual thermometer. In order to do that, you're going to need a couple different things. Some folks may use hot glue, some folks may use an epoxy or silicone. It's completely up to you what you want to use, but you need to make sure that this is waterproof. If you in fact make this non-waterproof, you're going to be replacing thermistors over and over again. Why is that a problem? Because if this was $12 on Amazon and you go through 10 of them in a day, it's not going to do you any good. So you need to make sure that you can actually encapsulate this and make it as waterproof as possible. The other portion to this is, and this is clearly stated in the rules, you cannot buy a pre-bought thermistor with the actual, what I call a wand, or the actual straw itself pre-made. I need to be able to prove that I can take this out after the actual event is ran to prove that I can get down to this holistic piece, okay? So let me say it a different way. If you bought this pre-bought and it is perfectly silicone together and I'm not able to remove the thermistor, then that violates the actual rules of the competition and you can be eliminated by disqualification. The reason for that is the pre-bought ones are already predetermined and configured to do temperature. Yours cannot be pre-bought for that one reason, and that's why. All right, variances in this. Of course, I'm using a coffee straw. It's probably a decent idea, but you gotta have specific straws and you may not have enough surface area for the silicone or any of the actual hot glue for that. So I got a couple other straws. Standard, nice drinking straw. I don't necessarily recommend the elbow arm there because it may move around a little bit, but it actually is a good form of that straw, so you can use a standard straw this. Or what I call the super slippery straws. These are the giant ones. You can pack a bunch of stuff in here. You still need to make sure that the actual endpoint has the actual thermistor in there because we are measuring temperature. So you shouldn't have it, the actual thermistor stuck in the middle of it because the temperature gauge is not gonna be as accurate as it is if it's on the actual tip of the straw. All right? That is the complicated portions of the actual device for construction. Remember, you need to construct this before you get there. A couple different things. Suggestions. I would probably have more than one actual measuring device. Have a backup just in case, because if you're in competition and your main one shorts out, you don't have time to go and glue something back together to make it work. So have a backup. The second part of it is you need to bring your own thermometer. Not one of these thermometers. This is old school. If you're sick at home, you put this in your mouth, it tells you how much the temperature is. This is not digital. It's not accurate enough to the nearest 10th degree Celsius for this to work. By the way, it has to be Celsius, not Fahrenheit. This is your standard thermometer. You can find this information online for the Science Olympiad as well, but this is what you want to be able to calibrate with. A couple things. One, you're bringing your own thermometer to regional tournaments. We will have ones at state and nationals. So we want to make sure that your reading is exactly the same of what you would test at home or at school. And then we take your particular temperature gauge that you've created, what's the thermistor at the end of it, and we put that in water, okay? Now, the first part of it is you get to play and test and calibrate the solutions of water in the room prior to the competition starting. They will not be the 4 stations that are in the rules. This is simply to make sure that your thermometer is working properly and that you can actually measure a range on your own. When you get to the 4 stations for the competition, you will bring your thermometer and your actual thermometer that you built that's connected to either a calculator or a laptop and be able to put them in the water together. All right? Let's talk about the stations real quick.